Hi and welcome to day 7 of functions. Today we're going to be talking about inverse functions, and what I have done is actually written out the definitions for you ahead of time. So an inverse function, you switch x and your y. Literally just take your x and put them where y was and y put it where x was. If it's an equation, we then solve for y and use f to the -1 of x notation or f inverse notation. When a function is one-to-one, that means each element in the second set, which is my y values or my range, corresponds to only one value in the first set, which are the x values or the domain. So what that really means in English to you is the y values do not repeat. Just like with a function, the x values didn't repeat. Well, when something is one-to-one, the y values do not repeat. And if it was a graph, it would pass the horizontal line test. Something else we need to be able to identify is onto. If a function is onto, that means all the elements in the range, which is the second set, or the y values again, are used. So this first example here, up at the top, right here, is an example of onto. Onto means all the elements in B are used. Over here, on the right, this is an example that is not onto because 8 and 1 are not used. For this one over here on the bottom left, this is one-to-one because the y values do not repeat. Even though I didn't use them all, that doesn't matter. That just means it's not onto. And for this one over here, it says it is not one-to-one because the y values repeat. And we could say that H mapped to 2 and O mapped to 2. So the 2 was used twice. Looking at a graph, this first graph here of f of x equals 3x minus 4 is both one-to-one and onto. It's one-to-one because it passes a horizontal line test, and it's onto because I'm not ignoring any of my y values, I guess you could say. My domain was all real numbers, and my range is all real numbers for a line. Therefore, it is also onto. On the right-hand side, the parabola, that fails the horizontal line test. HLT, horizontal line test. Okay. It is not one-to-one because the domain is all real numbers, but yet my range here, my domain is all real numbers, and my range is got to be y is greater than or equal to -2. So I'm not using all the values. Okay? Again, if I draw my horizontal line, bottom left, it passes the horizontal line test, and it is onto because my domain and my range are both all real numbers. Over here on the right, again, fails the horizontal line test, so it's not one-to-one, and it's not onto because my domain is all real numbers and my range is y is greater than or equal to 0. Now, if you're given a situation where you have actual sets like this, A is both one-to-one and onto. It's one-to-one because my y values do not repeat, and all of my y values are used, therefore it's onto. So the one on the right is not both because the 8 is never used, so it is not onto. So that's because 8 is not used. Okay. Find the inverse for the given function and tell whether it is one-to-one and or onto. Find the domain and the range for the function and the inverse. Okay. So this is my original function. And it is a function because it passes the vertical line test, or the fact that my x values are not repeated. So this is a function. My domain for my original function is A, B, and C. My range for this function is J and K. It's not one-to-one. And that's because K is used twice. It's not onto. The L is not used. Okay, let's find the inverse. So literally switch the x and the y's places. Before A mapped to J, so now J has to map to A. B mapped to K, so K has to map to B. And C mapped to K, so K has to map to C. This is not a function. And that's okay, the inverse doesn't always have to be a function. It's not a function because my x value is repeated. So here. My domain for my inverse is J and K. My range is A, B, and C. This is one-to-one. Because the y values do not repeat. And onto because all y values are used. Now, if you look at this function, you notice that my domain and my range actually just flip places. What was my domain now becomes my range, and what was my range now becomes my domain. So when we said you switch x and y, you literally switch x and y. So the domain becomes the range, and the range becomes the domain. Just a little added something extra here. If your original function is not one-to-one, then your inverse is not a function. So if you look at the bottom here, it's not a function because k was used twice. So in my original function, it was not one-to-one because k was used twice. So when I find my inverse, it's not a function because I'm repeating my x values. Okay? Last page. This is how you find the inverse algebraically. Switch x and y, solve for y, rename the function with f to the negative 1 of x. So we're going to rename this as y equals 1/2 x plus 2. Now switch x and y. So x equals 1/2 y plus 2. Now get y alone. So I'm going to add 2 to both sides, so I will end up with, subtract 2 from both sides. So x minus 2 equals 1/2 y. And then in order to get rid of the y, 1/2 y, we need to multiply both sides by 2. So 2x minus 4 is equal to y. And if I put it into function notation, it'd be f negative 1. So my inverse of x is equal to 2x minus 4. For letter B, y equals x squared. Well, switch x and y because I don't need to rename it. So it's x equals the square root of y squared. And, oh, sorry, it was just y squared. My bad. Hang on. Let me try that again. Okay, let me try that again. It's x equals y squared. Now I need to get rid of the y squared, so I take the square root of both sides. So I will have plus or minus x equals y. When you're solving for a squared, you have to do the both plus and minus, so that's why I had to put the plus and minus there. And then I just need to rewrite it in my function notation. So f of f to the negative 1 of x, so f inverse of x equals plus or minus x. My last one is just a line, y equals 3x plus 5. So switch x and y, so it's x equals 3y plus 5. Subtract 5. X minus 5 is equal to 3y. And then divide by 3. So you have x minus 5 over 3, or 1/3 x minus 5/3 equals y. So we rewrite that as g, because this is g not f, of negative 1. So inverse of g is equal to 1/3 x minus 5/3, or we can rewrite that as g inverse of x is equal to x minus 5 over 3. Alright, that's really it for inverse functions. What you have to remember to do is switch x and y and solve for y when you have an equation. When it's just in the picture form or something graphical, just again, switch your x and your y values. Alright, I will see you tomorrow.